Alright, good afternoon everyone. Welcome to our second lecture of week 7. What's happening in the course? Alright, assignment 1 was due Monday, so it's now 3 days late. UNSW standard late penalty is 5% per day, so you can still get 85% of your mark if you submit. Well, I guess you're 4 days late as of now, but you can still get most of the marks if you submit in the next 12 or so hours. I'd strongly encourage you to submit whatever you've done and get some marks if you haven't submitted assignment 1. If you have a special considerations approved late penalty, this doesn't apply to you, of course. You have whatever the special considerations approved for you. But everyone else, you've got up. UNSW's rule now is up to 5 days past the due date, so you have until I think noon Saturday to submit, with the late penalty increasing every hour by 0.2%. Assignment 2, yes, good question in the chat from Shattuck. Assignment 2, Dylan did some stuff for me and I haven't had a chance to look at it. I'm hoping to have time for that tomorrow afternoon, but I think it probably fits pretty well if we can get the assignment out. I'm not sure we'll get it out in time for you to read it before Monday's lecture or Thursday's lecture, but it'll be out for next week and we'll talk about it in one of the lectures next week. I think we're pretty good for the material you need for next week's labs. Next week's lab, you get to do a little bit of machine learning to the wonderful task of, given some song lyrics, guess who sang them? So you'll write Python that input song lyrics, output singer. Don't worry, we do all the machine learning bit for you, but you just have to code it up in Python. Alright, so yeah, assignment 2 coming soon. Weekly tests. You've got 2 weekly tests due at 6 o'clock today, so just after this lecture. One was from week 5, way back before flexibility week, is shell, and one from week 6 is our first Python weekly test. Make sure you've done both of those. Remember, the weekly tests, it's the best 6 of your 8 marks, so there's no point not trying to do one of them, even if maybe you'll do better than you think. So anyway, all right, so that's what's happening in the course. Now, where are we? I wanted to work through using stuff from Python this week. So I'll recap a bit about regular expressions in Python. You'll remember Python has a more powerful set of regular expressions than are available in generally in what we've seen so far in sed and grep and tools like this. It's the same, more or less, powerful set of regular expressions that's in Perl, and there's quite a few languages that give us a similar set of regular expressions. There can be annoying little differences, but there's a widely used library called PCRE for Perl compatible regular expressions, which is in a lot of places and languages. Python provides this more or less. We'll focus on the core things, which you'll get. So there's powerful regular expressions in Python, but available lots of places, including in grep by grep-P, but not in sed. All right, so let's first. There's a couple of key functions. The one that you have to know about for regular expressions in Pythons, and let's recap them just to make sure we know what they are. There is this one, re.search, the single most useful one. Does this regular expression occur in this string? The result is an object which can give you more information about what happened, but often we don't care. We just want to know regular expression match, true or false. So we can use it to control a while, or more often an if. We'll show you using that shortly. What else we got here? 3 more great ones. So re.search has 3 functions. Now, Python is not shy of giving you lots and lots of choices and throwing in some extra things that are sort of useful, semi-useful, you can do already. Well, I guess, yeah, what would my point be? Some language designers would say, look, re.search does everything you need. You don't really need re.match or re.fullmatch. They're sort of convenient, but you don't really need them. The Python designers said, no, they're sort of nice. We'll throw them in there for people who want to use them. So there's lots of functions in there. So, but I wanted to highlight these ones because these are ones that you really need. My slides are jumping about. There we go. re.sub. Now, well, I guess when I say really need, you could also actually implement all of these in terms of re.search. You could, but re.sub is a key one you use. Replace occurrences of the regular expression with this replacement string in there. Oh, I've said this is a replacement string. If you want to get super clever, you can actually put a function in there, and it will be called with the match object, and you can then do weird and clever things there. We might show you that in some more advanced coding next week. Also really useful, give me a list of all of the matches for the regular expression. By the way, non-overlapping is there not just because I want to be pedantic. Nothing bad about being pedantic, but it gets a bit tedious if you want to put every case on a lecture slide, of course, unlike comprehensive documentation. But I've highlighted this in the lecture slide because this bites people. This is something that does get people. It's really easy to write regular expressions that might overlap in their matches in the string. Find all gives you non-overlapping matches, and that's something that does matter fairly regularly to programmers. And re.split, you'll mention I gave it a big shout out as like cut, but so much better. Right, so I've highlighted those. What else do we have to? Character classes, they're nice, they're convenient, they let us write more readable, more robust code. They're great. These two, well, not even two, just one. This one is, you want to impress if you want to impress your friends at parties on the weekend with your knowledge of regular expressions, go with \b. It matches at a word boundary. It turns out that's a pretty common thing we want to do. We might want to change all the instances, I don't know, of if in a program to, I don't know what we'd change it to capital if or something like that. But we don't want to match that substring inside words, and then we can put /b there and /b there and not match subparts of words. There are many tasks we've got. Change a variable name, someone's misspelled a directive, this software now wants this command with this word here. It's very common we want to do word-based changes, and /b is our friend there. Some of you might have figured that out with grep. It's pretty common to want to be using grep and be working with words, and grep has a -w option that says only do matches of whole words. Very useful. \b is similarly useful. You could actually get, you could use \b to get the same benefits as -w for grep. All right, R notation we talked about. There's a nice, here's using the match object. I'm not going to actually spit. You should try these out. So I put these here to try and encourage you to play with these yourself. You've got Python, at CSE. Almost certainly you must have Python on your laptop or your desktop. So you must have Python at home. Well, play with these things and make sure you understand them. So if I match this against this string, I get back an object. And as I've said, sometimes we just want to know whether the object is, if we got back an object to say the match succeeded, or we got none to say it failed. But sometimes we want more information, and the object can tell us what string it matched against. So we don't know that in general. That's a regular expression, it matches, that's an infinite set of strings. Sure, if it's a constant there we can figure it out, but if it's coming from input we don't know what it matched against, so that tells us what it matched against, which columns it matched against. So that's when I've said you could implement re.sub, the replacement function, using re.search. It'd be pretty easy. You think about it. Nice little exercise for you. Implement your own substitute function using re.search. It's only a couple of lines of code. Alright, now this is where the match object gets really interesting. Brackets. Brackets are overloaded. They have two meanings. They're used for grouping like arithmetic, and they capture. The capturing goes into the match object, and if I'm just using the brackets for grouping, well, that's the end of it. But if I want, I can get what part of the string matched against what bracketed part of the regular expression. Counts from left to right using the left brackets. If it's nested, you can't go left brackets. You can have nested brackets, and it goes from the leftmost bracket. So this is first left bracket, second left bracket, and so on, up to I think 99th left bracket. You shouldn't do that though. It's not uncommon to have 3, 4, 5, but beyond that you're getting into serious readability issues, and you should be thinking about your life choices, or at least your coding choices. So I've said here, word match against word characters, one or more spaces, and some more word characters, and I match that against hello Andrew, and I get the hello and the Andrew. Oh, this is quite scary. We can refer to the group in the replacement. So if I say \n in the replacement string, it's not quite a string. It's a string with a couple of special things. If we see \n in the replacement string, it gets changed back to the nth group. And this is a really common thing. Often we have substring in the wrong order, and we just want to swap them about. So we've got this and this, we want to rearrange them. Here's how you can do it. I've actually made a slightly more change there, but that gets me whatever matched there is this, and whatever matched there is that. It's incredibly powerful, incredibly useful, just all the time. And this is where regular expressions are winning. You can write reliable, robust, readable regular expressions at this sort of scale. You keep working at it, and you can generate regular expressions that are hard to debug, hard to read. But it's all a matter of coding judgment. All right, this fundamentally changes the language. This is, if you're a mathematician, being able to do this is earth-shaking. What I've said here is match some digits, a space, then match the same digits. So that matches two numbers, two integers, two positive integers I should say, separated by the same space, but it's the same positive integer. This gets called a back reference. It's impossible to implement with the classical regular expressions. So you remember I said Ken Thompson took the work of mathematicians, particularly the most famous one being Stephen Klein, and implemented it. His language didn't have back references. If you add back references, it allows you to create sets of strings that are impossible with classical regular expressions. It changes the theoretical foundations. Is it useful? Yes, sometimes. Sometimes back references are useful. They'll use with prudence. They can let you do some nice things. Mostly, you see people using back references in regular expressions, and they're doing stuff that we better code it up as if statements, while statements, string operations. It's certainly something to know about. Sometimes we've got to do quick operations on the command line. Maybe back references are helpful, but it's a great thing to know about because it gives you a different type of language. The classic one, by the way, which I think we got you to, I asked you, did I cruelly ask for this as a challenge exercise way back? I think I did. The classic one is match the set of strings that's 1A and 1B, 2A's and 2B's, 3A's and 3B's, and so on. You can't do that with standard regular expressions. Add back references and you can. All right. And it's actually something every person who works with code and regular expression should do is try and implement this match and even the same number of A's and same number of B's. And undergraduates have been doing this forever. I did this as an undergraduate. I think it was in a fourth year theory course, but the lecturer, it was a lovely guy who's now dead, said, try and do this, Andrew. And I tried and tried and tried, and he said, no, and now try it now and prove it's impossible. So yeah, it's something we should all see. Sometimes it can create problems if we capture with a group. There's a really bad syntax. Well, it's a hard to read syntax. I don't know if it's bad. I'm not sure what the better choices were. If you put a question mark and a colon after a bracket, they mean this is just a bracket, don't capture what's in it. Why do we need that? re.findAll does special things if you capture. So if you're using re.findAll, it can be useful to know how to create a non-capturing group. There are other subtle places where you need non-capturing. And there are other things you can put here inside brackets that I don't want to get into. But there are various interesting things you can put in there. Oh. So, you remember when we saw sed and the notion of replacing a regular expression match, that what the regular expression match, which part of the string the regular expression matched, became important. When we're just using grep, say, we just want to know regular expression match, yes, no. We don't care which part of the string. If we're replacing it, we do care. And a regular expression can match multiple parts of the string. So if I say A followed by one or more B's, that matches 3 places on the string I've got there on the screen. AB, ABB, and ABBB. So it's got 3 matches. Grep doesn't matter. Replacement, it does. So we need to know what it does. Now, you can try this out yourself. You have to try this out. I'm begging you, get Python up. Try these things out. We get told about these things, we form internal models in our brain, but is the model in your brain right or wrong? Well, I don't know. I guess I can give you an exam at the end of the course, but we really like to find out before then and correct and learn. So we can try out some things with Python. It's not mathematics. It's so much harder if you're a mathematician, but we've got something that will execute a regular expression for us. So as it turns out, regular expression matching in Python and most regular expression engines is what's called greedy. It matches the first place it can in the string, which will result in success. Not as simple as it sounds, because you can start out matching and then fail. So you can start, oh, I've matched this bit, this bit, this bit. Oh, I can't match the last bit of my regular expression, and then I have to start again. So, but the regular expression matches the first place in the string it can succeed, and then it makes the match as long as possible. So the first place this can, well, we can try it out. Yeah, there is another possibility here, but let me demonstrate. Let me power Python up. Let me get, so I'll power Python up. I'll make a string like the one we just saw with an A and 3 B's, a couple of C's, an A and 5 B's, and I'll do a substitute of AB plus 4, we'll turn it into a couple of X's, 3 X's, 1 S. I wanted to highlight something. Why have I put an R there? The answer is doesn't do anything. What does R do? R says this is a raw string. Backslashes just mean backslashes, with the exception of backslashes for quotes. We do it on regular expressions because we often want to put we put lots of backslashes in regular expressions, and we'd have to backslash the backslashes without the R. Why have I got it there then if I don't have any backslashes? I'm just used to it. It's not. It sort of gets to be habit. I think it makes the program more readable if you do that, but that's just me. So that would work just the same without the R because there are no backslashes. All right. Oh, it's done it's done everyone. So we have to. All right. Let's use re.match then. We'll get a match object. And match against that. What did this weird error message mean? It's really quite, yeah, you're not doing great there, Python. What it's saying is that parameter, I'm expecting an int. That parameter is the flags parameter, which apparently is an int. So I can say m dot, is it span? All right, and we've discovered, let me show you what S is. It's gone from 0 to here, these ones. I brought up this example because there is a longer match possible, but it's later in the string. So greedy matching means as soon as possible in the string, then go as far as possible. If you look at that regular expression actually has for 7 different matches on that string. So that's how you disambiguate it. Now, you're saying, I'm not greedy, Python has a way, the syntax is common to Perl as well. There is a way to say, I don't want greedy matching there. So that's saying for the plus, yeah, don't go any further than you need to. So you say plus question mark. Does that make any logical sense that that would be the syntax? No, you just got to accept it for what it is. Don't try and infer any sort of meaning to it. Just say plus question mark means a plus, but not a greedy plus. You can also put the question mark on an asterisk, or can you put a question mark on a question mark? I've never done that. I'm not sure. Does that make any sense? We don't know. Oh no, of course a question mark.
On a question mark would always be 0.
Yeah. All right. All right. If I show you the span of that one, the span will be shorter. All right. So this is quite useful to say, don't go any further than you need to. Particularly, it's common when this is dot or something like that, or you'll see it in more complicated things. All right, let's get back to my slides. Let's get talking through here. I want to get the code.
The Python reference says you can put a question mark on a question mark. I struggle to think of a reason that would be useful.
All right, now I wouldn't recommend doing this now. But in your holidays, if you think you're good at all of this stuff, what I'd recommend to you is you try and code up your own regular expression engine. I have thought about doing that as an assignment for this course, but it's very, very educational, because a regular expression in its matching can have to go arbitrarily far to discover it doesn't match. So I'm matching this regular expression, which is A, B's, and then a C. So I can start off here and go A, B, B, oh, no C. A, B, 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 oh, no C. A, B, B, oh, yay, C. So you can see, sorry. look, I start here and I go dum 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 dum, and then I have to go. Then I have to start. Then I start again. It gets weirder if the place I start again is in here or in there. You can construct regular expressions that jump about. Well, backtrack is the word. Wait until you've done backtracking. You might meet an AI, you might meet an algorithms. I'm not sure where you'll meet backtracking searches, or you can just Google and read about it. So there are a couple of things here. It's easy. Well, it's not easy. It is easy coding up a regular expression to make it get very, very slow on on maliciously chosen regular expressions. So there have been denial of service attacks, several of them, by people crafting regular expressions, and the regular expressions aren't particularly huge. They can be just a line or two of length, just 100, 200 line characters of length. We're talking of regular expressions that can make for a denial of service attack. You're saying there are websites that accept regular expressions? Yes, there are. I think there are a couple of morals there. One is you might want to accept only a subset of regular expressions in your website. Another would be you would sandbox the matching and resource limited it. And just another side note, we're not going to get into what NP is in this course. You'll have to wait for that, or again Google. But if we add back references, I'm told, I don't really understand it. Do I understand it? Okay, I sort of understand it. Understand it. Implement your own regular expression engine and you'll probably understand it better. But back references change the computational complexity of matching regular expressions in the worst case. There's a lot of practical stuff that would make it better. There's an interesting suggestion from the chat. Blake's saying, well, why don't you make the client's browser do the regex matching? Which is not the worst idea. The only problem is then network traffic. If you're matching against 100 megabytes of data, then you may not want to. Then you've got to transfer that. But yeah, that's certainly one thing people like to do if they're worried about these things is shift as much as possible of the burden onto the client's browser. So yeah, good thinking there. Zeng saying state machine transfer for regular expressions. Yeah, great idea, but Ken Thompson beat you by 50 years. But yes, exactly. That's that. And you can do clever things, and Ken Thompson really was the first. He came up with some of the ideas and that lets you do regular expressions efficiently with state machines. Apparently Dylan's volume is really quiet, but I'll bump that up. Okay. All right, I better get moving along here. Oh, well, that's now all I need to talk. Good, because I can get to what I want to do, which I want to show you some coding. So let's get to coding. Flick over to here. Oh, actually, no, I'll write that. There was one more thing I wanted to show. I don't know if I don't think I did. So this was the snap example I was working on that said snap, and I can't remember if I did do this with sets, but I want to do it with sets just to show you. Python has a nice set type, which is one thing you could reach for here. I could have a set of the line seen. Actually, I'll run that just to remind you what the job is here to do. So, oh, it's showing me the line counter every time round. There we go. So I type in lines. I go hello, Andrew, hello, and if I type in a line twice, it says snap, and that's showing out. I'm using a counter there. If I don't want the count, I could just do it with a set. And it reads beautifully. It's just to add to a set is. Why do I want to show you this? I can't. Sets don't have counts in them in Python. Well, simple sets don't. So that's a Python set type, and it's beautiful. So line seen is a set. If line in, line seen, spell it properly, Andrew, print snap, and then add it to the set. Isn't it? That's just code that makes your heart sing. If I spell, I guess there was a way I would know that would be lowercase. I can't think of why that would be, but there we go. That will do. It's making a good case for static checking, isn't it? I do have a static checker I use a lot, so maybe next lecture we'll get to that. Oops. There we go. All right. Just a set. I just wanted to show you that using a set added to the set to encourage you that you can do this with a dict, and it's not much different. It's just a little more beautiful with a set and a bit more readability. Sets have the usual sort of set operations there easily, like union, intersection, and things like this, by the way. And again, you can code them up yourselves, but it just makes your code, particularly if this is embedded in more complicated operations, if simplifying just a little bit, just making the simple stuff simple, so even making the easy stuff simple, so the user can focus on the key stuff, it can be great. Let's go back to my problem then. All right, let me set the scene. We're back to a familiar set of data. I have a file with every UNSW course code. I'm the only person with this file, well, except for you, because it's all on the course website. I manually construct this file. It's got every UNSW course code ever used. I'm not sure that's really true, but it goes back a long way anyway. And I've also got synthetic enrollments that look like enrollments in comp courses this term. It's not actually, these students do not exist. There's no privacy violations here. Everything in this file is sort of made up, but made up to look like real students. So what do I want to do? I want to know how many people are in each course. So I want to know how many people are in COMP1911, COMP4952, COMP1511, COMP902. I just want to do this, but I want to print out the course name. I can't remember all these course codes, so when I print out the count of students in COMP9511, I want to print out what the course name is. You're saying, Andrew, grep, you can grep. I know that, you can grep. Did you know you can grep? Yes, you can grep. And that's good. I like that reaction from students, because you've seen this tool and it's great, and you take and grep and cut, Andrew. That's it. All right, and we could embed that in our Python, and I'll show you in a later example how to embed shell in Python. But let me repeat. If you think I've got to do a cut, I've got to do a grep, I should be running them externally from my Python. No, you haven't got all of these things are easier to do in Python. Things asking, can we overwrite the in operator? No, you can't overwrite Python's operators, Zeng. Python's operators, though, call particular methods of objects, so you can specify for your own objects these methods and get your own results, sort of. Now, what am I doing? Oh, well, I've written up some code there. All right, so let me highlight a couple of things. There are a couple of things I wanted to show you. There was a great question in the last lecture saying, Andrew, how do you do constants in Python? Python doesn't really have constants, but this is what programmers do. They assign it to a variable, and then they just don't change the variable. Convention, very, very common convention, which I presume is codified in one of the Python peps, is put it all in caps, So I've done that, saying what the file names are. That's sort of nice for this sort of code. This sort of code is often utility code. It doesn't have to be particularly beautiful. You often don't go to all the effort of parceling it up into the functions we might do in other circumstances, but you certainly want these obvious things. If someone's looking at this code, their first thought is, what does it depend on? And there highlighted is, it uses this file and this file, so it depends on those. Right. Python has a weakness in that encodings. This code will actually probably work without those lines, but if you want to be really sure with current Python, you have to say how are things represented in this file. That's not something we'd hassle you about in this course, but I'm saying this is using UTF-8 encoding. If you haven't done COMP2041 and are not going to do COMP2041, Google UTF-8. It's a beautiful thing. It makes your life easier. It's not hard to understand. UTF-8 is great. Alright, now what I've done is I've written some code here. If you talk to me, you talk to Dylan, you talk to tutors who answer questions, what makes them sad is students who write lots and lots of code, and then when they've written 50 or 100 lines, try to run it, and they're just stuck because it's broken in 5 ways, and they can't figure it out because there's too much code, and the way it's broken in one way is stopping them debugging it in the other way, and it's all just too confusing. So it's good if we can execute some code, debug it, and then move on. So write 10 lines of code, get them working, write 10 lines, get them working, write 10 lines, get them working. Now often we get out to harder problems and that's not possible, but certainly when it is, we do what we can. So I've tried to write code here to print a line from each file. You'll notice that when I read the line, I'm getting a new line, and print adds a new line, so I'm getting 2 new lines there. So I'm getting things there. Alright, what do I do? What do I do with this? Now, you have to develop a reaction here. If you're a shell programmer, you've got data in a file, you're thinking, great, I'll work with it, the data in the file. Lots of shell scripts, data in file, that's what I want. I can run cut, grep, unique, for, I'm happy. It's not where you want it if you're a Python coder. What you want is the data up, probably in a dict or something better than a dict. So how do we get data from course codes.tsv into a dict? You've got to decide, what key do I want? And you can actually you can probably make it work in a few ways, but the sensible thing here is if you've got something that's guaranteed unique, are there 2 UNSW course codes with the same name? We can work that out quickly. So if I do cut minus F2, and then I do pipe sort, pipe unique minus D, that'll tell me about, there seem to be lots of course code. Yeah, I'm guessing there are a few courses called Thesis A, Thesis B, and Thesis D. But that's telling me all the course names that are repeated. Often there are postgraduate and undergraduate versions of courses and so on. But we're discovering anyway that lots of course names occur with different course codes. So what do we do? The course codes are unique though. If we look at line 1, there's no repeated course codes. Yeah. So we'll use the course code as the key. So we need to get the course code from the line. I'm going to do it with regular expressions first here. So I'm going to do an I'm going to go with an re.search. Now, this file is a very fixed format, so regular expressions are overkill probably here. So I'm going to write a regular expression that would actually handle a file with lots of possibilities in it. So let's go with this one. I like that regular expression. So what does that regular expression say? Well, it's got a classic bug there. I've forgotten to put the R there. I need an R. Alright, now that's better. That says find the first sequence of non-white space characters in the line, match against those, then match one or more white space characters, then match any number of any character up to a non-white space character. That will strip leading and trailing white space, or more precisely it'll ignore leading and trailing white space and break up the line on the first white space. So it'll give me the first non-white space segment, break it at the next white space, then give me the rest of the line up till, but stripping off any trailing white space. I don't actually need it for this file. This file seems to be not have leading or trailing white space. Often it's good to strip this stuff off even if we're not. So that's how we might do it with a regular expression. Then how do we get, so the course code should be m.group1, and the course name should be m.group2, and we can just put in the dict courses. And that's beautiful. Well, not quite. Let's try it out. How will we debug it? I guess we just, it's not C. We want to see what's in a dict. We can just print it out. Let's just try that out. Got that one wrong. Why is it saying? Oh, I'm definitely seeing showing courses is not defined. Well, it's a dict. I wanted to find it. But remember, for a dict, typically what we have to do is initialize it to be an empty dict like that. There we go. And that's good code, and that should get me all the courses into that dict. Well, is it good code? It'll work, I think, but there it goes. It's, oh. Yeah, we can read it, and so there's a course code, and there's the name of the course. So I know how to check it. Let's try it out in COMP2041. That should print out software construction if things are going well for us. If I write the file. All right. There's something I don't like here. We're not allowing for the match failing. So we'll get an exception here if the match has failed. So good code would do something there. I'm not so worried about this if we think the match never fails. I mean, you could put an assertion there, but it's not a lot of difference. So, but in general, yeah, you do a match. You should then see if it's failed or not. So, but I'm going to rush on. All right, I want the course code from a line like this: COMP1911 vertical bar this. All right, so I know how to do this. We'll do this one in a different way. We'll do it by well, a complicated word for it would be ablation. Get the whole. This is a great technique which you won't be used to if you've come from C programming. So I want the string COMP1911. I've got this huge string here. Let's start with that. So the course code here equals the line. quite a powerful technique, and the technique that's quite easy to get working and often quite robust and readable is to get a bigger string and then chop it down to the bits you want. Far too often you see students think, oh, I'll write this great capturing regular expression where I'll match this, capture this, match this, capture this, when they should have got the whole string, chopped in partial stages, broke it down and finished up what they want. In this case it's pretty simple. So I'm saying we'll make it a raw string and say from vertical bar do that, replace it with that, on the course code. What we might do is, again, rather than rush on to writing more code, let's just print it out and break and see how we've got. So I'm hoping this will print out COMP2041, which is the first line in that data. So let's see how it went. Oh, it failed. That's weird. All right, have you spotted it? You'll probably spot in a second. Let's print out the whole line to make sure we've got a whole line. We've got a whole line, and then nothing. Yeah, Blake saying, why don't I use a string operation? Yes, you could do this with a string operation, and maybe it would be better. But let's solve it with a regular expression. This is not such a hard task, so it could be solved with a string operation. What's the problem here? This is a classic one for regular expressions. This is why programmers get a bit worried about regular expressions. At vertical bar. Alright, here's my coding tip for regular expressions. Every time you put a character in a regular expression, if it's not a letter, not a digit, ask yourself then, am I sure it's not part of it that has a special meaning added to it? So if it's not a letter or a digit, maybe it's got some special meaning. If it's got a special meaning, you'll need to backslash it. You're actually safe backslashing it if it's not a letter or a digit. Vertical bar, of course, has a special meaning in regular expressions. It's alternation. So I want to match an actual vertical bar, that one there. What does that regular expression mean? It means replace nothing or any number of characters with nothing. I'm not entirely sure how that would have matched, but the end result is clearly nothing. That should work for me though. Oh, except I've forgotten to print out the course code. Oh, there we go. Alright. Now, I'm a little bit worried about that extra new line there. It would be another tip. Well, this will strip off any white. Often this is the one you want. R strip. It strips off any white space from the right hand side of the string, including a new line. So this is a pretty normal thing to do because a lot of the time we don't want new lines. But that raises a big question for me if that works. And it did. I said replace a vertical bar with then any characters with nothing. But it doesn't seem to have worked. Let's haul out repr to really see my problem here. You remember repr is nice. It turns a string into something we can, well, it turns into what you can put in a Python program, but it's so good for debugging. So before and after. Let's go. Look at this. That's a bit scary. I said vertical bar, then any number of characters, turn it into nothing. And it almost worked. It got the vertical bar and went all the way down to here, but not the new line. It left the new line. Alright, so the full part of the story is a dot in a regular expression does not normally match a new line. What do you do about that? There is a flag you can put in whose name escapes me, which says I want dot to match new lines, so you can look up that and put that in. You could actually put a new line in there. What did you say? I guess any number of new lines or something like that. That would solve the problem. Because of the circumstance where it's coming in, probably the best thing is just to strip it like that. I think that's probably the most normal code. We often like to write normal code, so if people reading our code see code they expect, it's often better to write normal, obvious code that everyone writes rather than write it one line shorter or so it runs 3% faster, because then the poor person reading our code sees and think, oh yeah, I know what that does, I've seen code like that before. So that's pretty normal code. Alright, so here I can do counts, course code plus equals 1. Put the counts here, and then I'll print out the counts. I hit the classic problem with dicts now. Let's show it to us. Let's see it for ourselves. The first time there's nothing in here and we're saying plus equals 1. So we have the special case the first time. There is a way out of that, but not using dicts. Well, there is a way out of it with dicts as well. But let's do the brute force approach. Brute force approach if course code not in counts. This is there are about 5 different ways to work around this, but I'll leave that. But it's important to see this. You can't get a value from a dict by default unless you put a value there, which is what I was trying to do. That's printing out now all the counts we've got as one huge thing. That's not particularly useful to us. So let's dump this out. What do we want to do? Let me show you a nice trick. Actually, not a trick at all. It's an important coding pattern. All right. If I say dict, so that's a dict, and I say its items method returns key value, key value, key value. So it returns the key value pairs for the contents of the dict. And so often that's what you want to iterate over with your loop, to go through with your loop. That puts me now here. In, what do we say, course code. Now there's a complaint in the chat, Andrew, you're reusing names. I would say in a script like this that's actually okay, but the complaint has some validity. It certainly creates the possibility of bugs. The problem with writing code like this in one gigantic script is there's no scope. And it's okay to hack up something like this, but it's not an easy way to debug. What's the solution? Function, function, function. Put everything in separate functions. So that would be a better way to do this. So this code is not ideal in its functional decomposition, is what I'd say. Now, course code, course name in counts.items. Now what am I doing with that? What am I doing with it? Oh, it's not a course name, is it at all? It's course code. It's enrollments. It's how many people are enrolled in this course. I'm sitting here looking confused. I need to get now's when the dict we've done up here comes to the party. Courses, course code. So this should give us the course name. This is so much of this type of coding. I've got file 1, file 2, 3 with data in it. I snarf the data up into dict 1, dict 2, dict 3. Then I wrote code that does stuff, fetch and gets values from the dicts and puts stuff out. So much coding, and it's so useful to be able to do this quickly. So I do that, and then what am I going to do? Just print it out, I guess. Print out. I'll use an F string here to get some formatting happening. I'll print out the enrollments, the width of say 4, and then just the course code. So I'm using an F string here. I wouldn't need. I could do this without an F string. It's not really any huge thing about using F strings, not using F strings. But I'm getting the formatting width there, saying pad that out to 4 spaces. You're saying, what does that do? Well, I guess I'll just run it and show you. So I'll count the enrollments. So close, Andrew, so close. Will I count the enrollments now? Alright. That's not bad. So they're the enrollments in. Oh, well, I want the course code as well. Let's tuck that in my F string as well. That would be better. So they're their enrollments. Where's COMP2044? Oh, how do I find things? All right. Yeah, we've just discovered something, and this applies to keys, values, and items. The order they come out in is not necessarily the order they want. I'm honestly not sure what order they do come out in. Perl changed what happened here for security reasons, and I'm not really sure if Python's done that or not. But I
know the history of this. It used to be that dictionaries were randomized in Python. That's what Perl does. It's what a lot of languages do for security. In Python 3.6, a new algorithm was created which was more efficient, but it had side effects that dictionaries became ordered. So dictionaries since Python 3.6 are in the order that items are added to them.
Really?
But that's just the side effect of the algorithm used. It's not a guarantee. That could theoretically change at any time. You should not rely on it. It's not guaranteed as part of the dictionary.
So there is actually a different a version of dictionaries called ordered dict that does guarantee that, which is quite useful. All right, I'll take a breath and answer Art's question. Art's asking, when are assignment 1 marks being released? We've still got assignment 1s coming in. I've never seen so many students sick, by the way. And this is a record for number of students with extensions due to illness. I think combination of COVID and flu, most of them. Well, some people with COVID, hopefully no one with both. That would be bad. So they have a lot of people have a week extension, which means they're finishing off their assignment by Monday. After that, Dylan will be hot on the marking, which is a non-trivial undertaking, but we should be able to release early next week your marks for the 80%. the other 20%, we'll get it out to the tutors, and if we can get it out to them next week, there's a good chance they'll have it done by the end of next week, because people are not incredibly busy like they are in weeks 9 and 10. All right. That side note. Oh, we've got to take a break as well. But look, I'm almost there. I so strongly recommend that when in other languages, in these, in generally, this applies to quite a few languages, JavaScript, Perl spring to mind, but there's a pile of languages, that even if you don't really need these things sorted, unless you've got a good reason not to, I'd sort them and get a guaranteed order, and it makes debugging easier, it avoids issues, it's a predictable order is good. You're thinking, a sort of unpredictable order that might give me some security? No. A lot of people fall down there, is they think something's sort of unpredictable, and the malicious attackers, no, they're clever and they look at what's really happening and figure it out. Famously, there was an attack on poker machines in America, though the poker machine code was written here in Sydney, perhaps by ex-students from this course, where the poker machine wasn't producing random numbers as unpredictable as it should have been. Anyway, all right. So here we will put the things into a predictable order. All right, and we'll get that printing out. All right, and that's quite pretty. That's a count of things. So that's taken us. So regular expressions are overkill here, but doing stuff like this, that is so powerful. So it's not quite needed here, and I'll show you after the break, dropping that back to just a string operations. But understand all of this. This is lovely code. This is classic Python. This is you want to know all of this code in this file. We'll work through a few more versions, but I've got to give you a chance to stretch, get up, go to the bathroom, whatever, go outside, sun's out for a little while. So back in 5 minutes, so 5-minute break. See you shortly. Hey everyone, we're back. Alright, let's keep moving with this example. There was a suggestion in the chat earlier, there was a good suggestion in the chat earlier, saying, Andrew, this is a bit overkill. You could just use string operations to break up the data. So remember, we've got a file with data that looks like this, and we want to split out the course code and the course name. So here I've done it with a string split operation. We've just said split up the string on /t, and I've said don't do more than one split. There shouldn't be more than one split, but I thought I'd show you the max split operation. So I can, instead of doing those three operations, I can do this operation. I'll get an exception there if there isn't a tab in the line to split, but I'd get an exception from the regular expression. In both cases, I'd think about them handling in some circumstances, but at least with Python, I know an exception will stop the code. So I could change those three lines to that, and that should work. What about this one? Oh, that's not right actually. So I want to see if I split up the line on vertical bar, and then say I just want the 0th field, that should do what I want. I think that will give me the same code, so let's try that out and see if I got that right. Oh, almost so close. I should have still. You get a line there, you probably want to strip it. There are a few ways to do this, but this is the most common. There we go. And that's the problem solved. Now there is another possibility here. Python actually has a special collections object for counting, which is collections.counter. I can get one of those, and then I don't have to worry about the default case, so I can just do this and simplify my code. So that's an example of reaching for this extra thing included in Python. If I get it right, you can look at the class collections if you want to see what's there. There's some various interesting things there. And what have I done? Oh, and I'm an idiot. This should be collections.counter. That one stays a dict up there. That will be simpler. And I think that, so this is perhaps a place we didn't need the power of regular expressions. No. This time for sure. There we go. So perhaps we didn't need the power of regular expressions there, but there are places where you can't put a regular expression there in this doing a string split. There is an re.split you can use if you want to split on a regular expression. So the string split operation is more like cut, though this can be multiple characters. Cut can only be a single character. All right. Yeah, I think I've done with that. What I'd like to do now is, look, I'm looking at this enrollments file and I'm thinking, yeah, what are common names? Laura, George, Henry, Chiakwi, Zihan, Marco. What are Aiden? What are common names? What are the common names among students? So I'd like to count first names. One thing I would note is, for example, check here, Henry is enrolled in COMP2041 and COMP3141. So a student might be enrolled in a couple of courses. So we only want to count Henry once, even though Henry is enrolled in more than one course. So we need a unique identifier for Henry. And look, lurking there, every UNSW student has a unique number. You knew that. So we can use that. So I want to count first names and see what the most common first names are for students taking comp courses this session. Alright, so I've got a file. I'll chmod it while I think about it. Yeah, alright. No longer need the course codes. Oh. We can still use the counts though, can't we? How about we have something like a ZID scene, which is a set. Alright. Now we've got to get the first name. How do we do that? Yeah, this code looks useful, but I'm going to comment it out for now, maybe come back to it. Let's print out a line and break, and then go from there. Alright, that's not very good. That's doing the old thing. Let's run it again now, doing the tab in. Uh-oh, what's gone wrong there? Oh, there we go. That might be better. Oh my god, what's... Alright, I know what to do. You're saying, Andrew, use an automatic formatting tool. Here I'm doing first things and first principle. I've said to cat, show me the characters, and it's shown me, look Andrew, you've got a tab here. Python doesn't like you mixing tabs and spaces. Honestly, no one likes you mixing tabs and spaces. There we go. This time for sure. So it's stopping there. Alright, from all of this, we want to pull out hue. How are we going to do that? I think we've got part of the operations from before. We'll dump the new line. We'll try that. What does that do? Line.split. I think that gives... Let's have a look at that and then stop. See if that gets us any closer to hue. Getting that first hue there. Ah, there we go. Alright. So we've got a list of 3 things from the split. Yeah, split turns a list, not a tuple. I wonder why that is. Oh, 3 is 2. You're saying, Andrew, why have you got that magic number, that 3 in your code? Good question. It probably should be a constant. That's got the whole name. Alright, so I've made some progress. See what I mean about execute it, work out what's happening. Don't code up 50 lines here trying to solve the problem. So this is the full name. So we've got the full name. And if you've got a part of a calculation that you can give a logical name to, it's so good to do so. It makes your code so much more readable. Alright, we want the hue. How are we going to do the hue? I'm going to do it with regular expressions. I'm going to use an re.search for comma any amount of white space. There's probably always a space there, but who knows. Then I'm going to call the first name all the non-white space characters. You're saying what about someone who's got white space characters in their first name? Yeah, it's not going to work for them, but then this whole format doesn't work for them. You might be saying no one would have white space characters in their name, but have you seen the name of Elon Musk's children, for example? So yes, we'll make the assumption that there are no white space characters in the person's name. Someone with white space characters in their name probably gets their name mangled by a lot of IT systems. So we'll search for that in the full name. And hopefully that'll give us the first name. From group 1. There we go. And we'll print that out. And if things are going well, we've got Hugh. Let's try that out. Alright, let's be brave, take the break out, run it for all the students. And you see what I'm talking about. All of this is probably the one Angus in 3 courses, the one CUN in 2 courses, the one Arthur in 2 courses. So we've got to use the ZIDs, but we know how to do that. Probably not the best way to do it. The ZID is that one. So how about that for that? Looks like it might work. Modulo my lousy typing. Alright, so that looks like we're only counting each ZID once. Let's move to counts the first name. We can't say plus plus, this is Python, plus equals 1. And let's print out the counts and see if we've got something sensible for our counts of first names. Point. That looks pretty good. So there's a print of a gigantic dict and saying there are 12 Caitlyns at CSE this term. Oh, 12. Oh, seems to be some sort of ordering going on here. A little weird. Anyhow, all right. Oh, it's the counter object. What does it? How weird. All right. So now we just can do for name comma count in I think apparently a counter object will give it to us them sorted, and we'll print the count in a field of 4, I guess. And actually, do we really need to? I don't think we need to. Count comma name. See how we do with that. Alright, I'd like to have this sorted in order of frequency. If I do, my problem is if I sort this, a sort on a list of tuples sorts on the first thing in each tuple first, and the first thing in these tuples are going to be the name. So if I do this, I'll get it sorted on names. But I want it sorted on numbers. Let me show you a trick for this. There might be another way to do with this counter objects, but there's this classic problem. Let me show you the problem here. Is I'll print this out, and I'll print out just the first 10. I'll use a slice just to print out the first 10. And I'll exit. Oh, I don't have sys in. Let me just do that. Let me show you that. So that's sorted on names. I've said sort this list, so it says it arranges things, and to sort tuples it compares the first thing in the tuple, and if they were the same it would go to the second thing. But there's this classic trick then, which appears in Python and many languages. People give it a name which I've forgotten, but I'm sure many people have independently invented it, of rearranging the tuple to allow you to sort it in the order you want. So I can't think of a good name. So we want the count and then the name. We can use a list comprehension, which we haven't properly covered, but sort of just should make logical sense like that. To swap round, to get a list with the tuple order swapped. Do that, print out the slice of the first 10, and we should see them in increasing orders. I want them in decreasing orders, so what I can do then is just reverse the sort. There is a Python reverse function, but sort also has it. It's such a common thing to want. It's like almost a 50% chance. Which way do you want to sort? Though the trick, there is a trick to reverse sorts, which is to make the numbers negative. We won't do that though. We don't have to here. If you swap the sign of the numbers, you'll get the reverse. Then you can de-swap the sign of the numbers to print them. Old programmers' tricks. Alright, so this gives us from least common to most common names at CSE. According to this, the least common name is Kit, and there's two people called Kit. This is synthetic data though. It's throwing away names that are rare because it just so it doesn't make much sense for rare names. But if we look at the most common names, here's the most common names. Most common names are Yi, someone who doesn't have a dot, Zhao, Xin, Zhu, I'm mispronouncing all of these no doubt, Amy and so on, Ray, Ziheng. So there's the common names from the data. Done with this. So if you haven't understood this, take the time, cut and paste this code into your terminal, understand this rearranging tuples trick. You need it over and over in lots of places. K-Sure it doesn't like my first 10 slicing. Is saying, Andrew, that 0, you could get rid of it. Yeah, all right. You could omit the 0. That is true. Is it more readable like that? That would be my defense. Hello, Clayton's asking, can you use a lambda function? Yeah, we'll come back. I want to show you more powerful sorts using lambda functions. Might come back with an example sorting dates using a lambda function next week. That's using split yeah, that's all very good. All right, I think that's all. Oh, anyway, now I wanted to show you another way to do this code. What did I want to show with this? I just want to show you a way you'll see a lot of Python programs. I asked Dylan to do this, he'd probably do it this way. If I want to break up and put it in a couple of fields, I might do this. So if you look at enrollments.txt, so they're the fields. So the first one is the course code, which you don't care. Then there's the ZID, then there's the full name. So I might just assign them to a tuple. So I might get the first, oh well, just for K, there we go. That's a pretty common way to do Python. So split up the line and get a list, and I've said select the first 3 things from the list, then assign them to that. This I don't. You could put the name of the course. You could put course code there, but this is a common sort of Python thing to say. I don't want to use that. I don't want to have this variable name only used once, so I'll put an underscore there. And that code all should do the same thing. Is that correct? Oh, would be if I spelt full name properly. See, so this, it terrifies you, doesn't it? That is there lurking in your Python code base these things? So that's why you want static checking. All right, so that's this. I want to show you that. Get a list of values here, pick a couple, and assign them like that. It's a very Pythonistic, Pythonic. Oh, all right. I'm getting sledged from the chat. Someone's saying, Andrew, you can do better. Yes, I can. You can always do better. So the suggestion is I do 1,3. There's always someone in the chat that knows better, and they're right. So, sorry, who suggests Duke? Yeah, so well done, Duke. Yes, that is better. Some nice coding there. All right. What did I want to do now? Oh, all right. What about if I want to count the first names within courses? So I want to count, maybe I want to count report. If there are more than 5 people, I'll declare a constant for it. More than n people in a course with the same name. So do I want to do this? Yeah, no, let's do this. We're set up. We're ready to go on this. We've played with this data. This ties in well into the. I'm just hesitating because this is so. This sort of ties into next week's lab. So I could do it on Monday, so it's fresher in mind. But no, let's do it. Actually, no, let's do it now. It's actually probably better to do it now. So if people start next week's lab a bit early, they're good to go. All right. So this example is designed to lead into next week's lab exercises. So we want to report more than 5 students in any one course. If COMP2041 has more than 5 people called Amy, we want to report that. How do we do that? We don't care about ZIDs. A student can only enroll in a UNSW course once. So we want the course code and the full name. Can you actually... Now my Python knowledge is really... I should know this. But let me demonstrate. I've forgotten whether Python will let me do splits. I know so many languages that you sometimes forget. Will it let me split out the third and the fifth element like this into a list? No, it won't. Is there a way to do bit slices of a string, Dylan? So if I want elements...
I don't think so, not on a list.
Okay, alright. Alright. So we're back to this. We're back to using my underscore. Well, that's good. I can use my underscore now. There, we're back. We don't... That's... Right. We don't need to worry about ZIDs because... But now we want to counts for course code and first name plus equals 1. And well, I've got a problem. We'll do it all as dicks. I'll show you the full horror with dicks. So if we count it like that, then we have to then say, if we're going to have a dict of dicts, it's not the only solution here. There's a few solutions here. You can come up with your own clever solution, but it's important to understand the simple, most obvious, I'd say brute force solution to this is. So if we haven't seen this course code before, set counts course code to an empty dict. If we haven't seen this first name in this course, set that to a 0. So if first name not in counts for the course code, this is ugly, but it'll work. Set that to 0. I don't want, well, I want something like this, but so I'll comment it out. But this is so let me encourage you. Python prints anything, and if it's a weird thing, repr is your friend. But we've done all of that, perhaps too much. Perhaps we'll be brave though. So I would say I've gone too far here without doing incremental checking to see I've got success. There's probably a million errors in there. I meant to change the name here, damn it. What do I call it? More than 5.py. Write it. Alright, so it's meant to, we're trying to report if there are more than 5 Amy's, for example, in this course. Is it doing the right thing? Yeah, well, maybe. It's a bit hard to tell, really, isn't it? Seems like it. Seems like we've got a dict here and COMP2041, and it's got 2 Owens, 1 Sophie, 2 Leos, 1 Lachlan. There is a way out here. Oh, my mind's failing. Dylan, what's the pretty printer? It's pprint, isn't it?
It is pprint. Pprint.pprint.
pprint, prettyprint.prettyprint, I think. So for your debugging needs, there is a pretty printer in Python, if I've got it right. You say, Andrew, I'll never remember all this stuff. Remember, you've got access to the documentation when you're coding, in exams. We never force you to remember all of this stuff. So I think that will print out that dict in a lovely way.
I am missing that extra P. pprint.pprint.
The module is pprint. And we're good to go. And it does seem to be doing the right thing. I guess how would we check? Well, one thing we could do is we could write greps and sorts and uniques. It's tremendously useful to be able to sort of sanity check stuff. And that's we'll often reach for filter. You'll find yourself in future years reaching for the filters, this stuff that we learned in the first weeks, and you hone to relentless precision working on Tigger. You'll often find yourself reaching for this to sanity check code you've written in Rust, or you've written in Python, or you've written in Perl, to just do a quick check and compute how many Christophers there are in COMP2041. So I guess I'm talking a lot. So I can say grep comp9727 dot star Christopher in enrollments.text. Oh, there seems to be one. What did that just say? There was one Christopher? We'd have to go back and check. But anyway, you get my point. All right. And you see the pretty printer gives us a lovely view of this dict of dicts. So that's sort of nice. So file it in your brain for future reference. If you want to pull apart it, you want to see what's inside a dict, it's your friend. All right. Looks like we've got that. So let's go through this then. So how will we go through all of this? So we can say for course code in, let's say sorted again, counts.keys. Yeah, that's probably what I want, isn't it? For there is a, well, you could do this slightly differently, but again, there's a question. If you really understand what dicts are, you could use an items on the previous loop, but is that good? I'm not at all sure. And what do we want? Report more than students. And now we can just say course code has I'm there. Students named and their first name. And away we go. What could be easier? We should have a report on common names at CSE by course, just like that. So coded up in front of your eyes in a few minutes is this. It's not beautiful. It could be. You could spend half an hour tidying up, cleaning it up. There's a more beautiful version on the website, but it works. Counts across this. Right, so that's done with a dict of dict. Is there another way? That's sort of complicated. Yeah, there is another way. What key can we use for a dict? Almost anything. Almost anything. You can use anything that's immutable, unchangeable, anything but lists, anything but dicts. So your key can be a tuple, provided the tuple doesn't contain a dict or a list. Tuple of tuples, tuple of strings, tuple of integers and strings, tuple of tuples, of integers, of tuples, of integers. No, integers can't have tuples, but you get my point. Anything immutable. So what does that let me? Why don't I use the course code and the first name? Here's my idea, and I really wanted to show you this because this is common across a lot of languages. You just do it in different ways in different languages. So you talk to someone who's coded in a few languages, they'd be reaching for this, but they'd just be wondering, how do I do it in Perl? How do I do this in Ruby? I know what I want to do. I want to find a compound key from these two things. How do I do this in Perl? So I make my key the course code and the first name. Oh, if I do that, well, I'll amend. I'll do it with a dict first, but we can then simplify again. Oh, there is an issue there, isn't there? So my key is tuples, so I'll get a pile of tuples back. What am I going to do about that? Yeah, I think that's okay. Oh, it's going to be really weird code, isn't it? I'm liking this. Alright. I can bring my loop down in and that's items. Yep. Bring that back out. Does that fly? Not quite. Let me fix this bit. So close, so close. What have I got wrong? Oh, counts key. Yeah. That's better. I'm going to make this better still shortly. Ah, there we go. Alright. But I can go to using a collections counter object and make things simpler still. I'm going to do that as I can. I love shortening code. I can do that. So this is a nice illustration. So a collections counter object is just built on top of a dict. But across Python, you could use in a lot of these places, they'll be asking for a set, for example, wants a hashable object, which is an immutable object basically. So I could have it put an object like this in a set as well. Because course code, it's a string, first name's a string, it's a tuple of strings, that's fine. Let me just demonstrate to you that Python will not be happy if this is a list. Lists are not immutable. If I make that into a list, Python will say, Andrew, I'm not going to do that. Make it a tuple, so it can't change. That's two items, always two items, whereas a list can be appended to. Do that, Python says, Andrew, you're great, keep going. Okay. I like that. And in fact, I could even get rid of that key variable. Should I? Yeah, I don't know. This code, this should be in a function for sure, and that should be a function, so that we should have several functions in there. Should I do that now? What's my next? I've got a few examples I want to work through, but I'm just trying to work out which one I should do. Oh. Actually, maybe I'll decompose this into functions. That might be a good thing to do. How would you decompose this into functions, Andrew? I'm sort of talking to myself, sorry. I guess we'd do an extract first name function, which took a full name. And we'd yeah, it does worry me seeing this match here and not doing anything if the match fails. It really does worry me that there's nothing there. Python, at least you'll get an exception, but still. I'll put a doc string in there. very good doc string, but we are where we are. All right. I know I don't like this. That's nice. Will that trailing double quote mess things up? Yeah, well, great question. Which I've written the file. I think we have proof that it doesn't. Alright, so we're seeing the virtue of triple quotes there. Thank you for whoever was in the chat, so I didn't quite spot it, who noted that I accidentally, well, actually it's no, I didn't accidentally. Well, there's a single double quote there. I probably wanted to put double quotes there and double quotes there and let me. I don't know why I'm annotating rather than doing. Okay, so triple quotes. The great thing about triple quotes is they'll only match another triple quotes of the right type. So the bad thing about single quotes is they occur all the time in regular text. You know, don't, can't, and things like that. Double quotes less so, but they can occur. So if you work, for example, if you're working with titles of books or movies, they'll often have single quotes in them. They might have double quotes in them. Triple quotes, not so likely. So triple quote will quote down to there. And it's nice for doc strings because we often want to put docs. That's in, so that's all good. Alright. Now, how about turning all of this into a function? Yeah, I can do that. How would we do that? Maybe like that. Count first names. Is that the bit I'd put? Well, anyway. I'd probably put the file as a parameter here. I think that's what I'd do. Yeah, that's what I'd do. Path name. And have this, so it handles any file. That probably reads okay. Try it out. Let it rip. Oh, that's beautiful. I wanted to show you a main. I'm not happy with this decomposition, but I'll show you a main. We'll just have a main function here. And we'll do the trick here of which would allow this to be imported by someone who wanted to use the functions. You remember this is the Python's programmer's trick to run code if the file is executed. If a file is imported as a module, the weird variable underscore underscore name underscore underscore is set to the module name. If it's run directly, it's set to underscore 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 main. What if you have a module called that? Don't start your modules with underscore for that reason. So that's gives me code that's and maybe I did mean equals equals. Thank you, Python. So that's what we see at a lot of bottom of a lot of Python scripts are. Am I being run directly? Execute this function to get things going. If I'm not being run directly, someone's just importing me because they wants to use my functions. So that lets us write Python code for two purposes. It can be run directly, or it can be imported by someone else who wants to use our functions. It's also pretty common to say, well, I'll put some test scripts here, or sanity checks, or something here. So it's often it will have code. It's not normal to run it directly, but if you run it directly, it does something. It generates an initial database. It does sanity checks. It does testing. It does something. So you may get a whole pile of Python files that you can run directly with some stuff there. All right. So one thing we might pass in here is you'd also see common code like this. If sys.argv, you might, if we've got a first command line argument, we might pass it into main. So you might in this do a little bit of argument processing, or not. You might put that somewhere else. I don't know. So we've got to first split that, otherwise we use that parameter we've got, pass that in, and we'll make that, we'll parameterize main for that. And we'll call it that. That didn't quite work. Right, so that's given us a main function that we can specify how many students we want to report more than. It'd be a miracle if all of that works. So missing bracket there. And we need sys. We always need sys. I find this a bit annoying that Python leaves its namespace so empty. But that's probably virtues to it as well, leaving, having almost nothing there. Come on, I just want to finish my lecture. Sys.argv, this time for sure. So now if I want to report more than 6 students, I can say that. If I want to report more than 4 students, I can say that. Find out they're in COMP2041 has 5 Kevins, 5 Jackies, 5 Kennys, 5 Ali's. Alright, so that's sort of classic sort of refactoring. I'm still not, I'm not at all happy with, yeah, that's probably okay. That's probably okay, but this one, I would, this code here that pulls apart a line, got to be a separate function. Hate that. But we're out of time. So the coding I've just worked through, perfect to lead you into next week's lab. You'll get to practice this, explore it, do it in next week's labs, where, as I said, you get to do a bit of machine learning and identify which singer sang which song. So thank you for tuning in. We'll get assignment 2 out to you maybe by Monday, we'll see, but we'll talk about it in one of next week's lectures. So, and it'll be Python, so you'll get to do some Python programming. All right, talk to you all then.